Welcome back to the Deep Dive. Today is Friday, January 23rd, 2026.
And the future is officially here, or at least the calendar is telling us it is.
It certainly is. And if you've been following the headlines or maybe just scrolling through your own company's Slack channels this week, you know that we are supposedly living in the age of abundance.
That is the phrase, isn't it? It's the one that's been, heavily prophesied in the scriptures of Silicon Valley for the last few years.
And now it's theoretically being delivered by technology.
Theoretically is doing a lot of heavy lifting in that sentence.
It really is, because while the promise of AI for the last 2 years has been abundance, abundant productivity, abundant creativity, the end of all drudgery, the reality on the ground feels, well, it feels a little different for a lot of people. We're seeing this massive inflating universe of what one of our primary sources for today calls glossy demos.
The demo candy trap.
That's the term. You watch a video on social media, right? And you see an AI agent book a meeting or write a perfect email, maybe even order lunch for the whole team, it looks like.
Right.
Like absolute magic.
It looks solved.
Exactly. It looks like the Jetsons. It's clean, it's fast, and it never misunderstands you.
Never.
But then you, or maybe your CTO, tries to put that same agent into a real enterprise system, a messy, legacy corporate environment with, 20-year-old software and confusing, contradictory policies.
Yeah.
And what happens?
It doesn't just fail. It collapses.
It really does.
As Vazuman, who's the CEO of Veric AI, puts it in the field manual we're analyzing today, these agents collapse like paper bridges in a monsoon.
That is such a visceral image. Paper bridges in a monsoon.
It is.
It just suggests that the structure was never even remotely built for the environment it was placed in.
It's violent, but I think it's accurate. We are seeing this huge disconnect between the hype of 2024 and 2025 and the operational reality we're all facing right now in early 2026.
So the mission of this deep dive is to try and bridge that gap.
Right. We aren't just here to complain about the hype. We're taking a stack of insights from Vazuman's latest work. It's titled From Demo Candy to Production Steel. And we're going to try and figure out how to actually build things that work.
I love that distinction. Production steel. It sounds durable.
It's the difference between a toy and a tool, right?
Exactly.
So today we're going to unpack why these agents fail, why good enough models are actually beating the so-called geniuses, why memory is the silent killer of your ROI, and this is the part that really stopped me in my tracks, why humans are actually security features, not bottlenecks.
That is a complete flip of the script. Usually we hear that humans in the loop are just slowing things down, or they're the thing we need to eliminate to save money.
We hear that all the time.
But before we get to the solution, let's start with the diagnosis. Why are these agents failing? We have the technology. The models, GPT-5, the new Claudes, they're incredible. So why do they break the second they hit the real world?
Well, it comes down to a fundamental error in our mental model. And this gets a little technical, but I think it's important because it explains everything about why your last IT project might have stalled.
Okay.
For the last 20 years, we have built software using what we call deterministic APIs.
Okay, let's define that for the listener who might not be a software engineer. A deterministic API.
Think of it like a clean pipe, a really clean, predictable pipe. Input A always leads to output B.
Always.
It's a contract. If you send a request for a weather report to a weather API, you get the weather report. You don't get a poem about the rain.
You don't get a recipe for soup.
Right. You get the data you asked for in the format you expect. It's predictable.
It's boring in a good way.
Precisely. And because that's how we've built software for decades, we tried to build AI agents with that same mindset. We treated them like APIs.
So we thought, okay, I'll just pipe the customer email into the AI, and the AI will pipe the perfect response out. Simple.
But the enterprise isn't a clean pipe.
No, it's definitely not.
It's a swamp.
A swamp. That feels a little personal, but I see your point.
Well, think about your own workday. Is it a clean pipe?
God, no, it's a total mess. I get emails that literally contradict the meeting I was just in.
Exactly. Workflows are messy, data is missing, or it's contradictory. Policies change because an executive sent an email 5 minutes ago that completely contradicts the official handbook.
And human behavior is just wildly unpredictable.
So when you drop a rigid, deterministic agent, an agent that assumes everything will go according to the script into that chaos, it just shatters.
Vazuman uses a metaphor here that I really like to explain this fragility. He talks about brittle sculptures.
Yes, this is the demo candy. A brittle sculpture looks magnificent in a museum case.
Right.
That's your demo environment. It's totally controlled. The lighting is perfect. No one is touching it. It's safe. It's been optimized purely for viewing.
But the real world is not a museum.
No. The real world is a pickup truck driving down a bumpy gravel road at 60 miles an hour. And if you take that beautiful glass sculpture and you toss it into the back of that truck, which is basically what a real company is, it's going to turn into dust before you even get to the end of the driveway.
So if we stop building these glass sculptures, what are we supposed to build? I mean, what survives that truck ride?
We need to stop over-engineering for perfection. We need to start designing for adaptability. This is the big shift from what the manual calls the watch to the firefighter.
Okay, unpack that for me. The watch versus the firefighter. I'm intrigued.
A high-end mechanical watch is a marvel of engineering, right? It's unbelievably precise. Every gear has a perfect place, a perfect function.
Total precision.
But if you take a single grain of sand and drop it into that mechanism, what happens?
The whole thing just stops.
It stops.
Okay.
It has zero tolerance for chaos. It's incredibly fragile because it's perfect. It relies on a closed system where nothing unexpected ever happens.
Right, which is the opposite of my inbox.
Exactly. Now, look at a firefighter. You cannot script a fire. A fire is, by definition, chaos. It's changing every single second.
You can't predict it.
A firefighter is trained to assess a chaotic situation, to reason through ambiguity, to ask for help when the roof is about to collapse, and to adapt on the fly. They don't follow a flowchart. They follow principles and training.
So we're trying to build agents that can think on their feet, rather than agents that are just following a very strict decision tree.
Precisely. The mistake engineering teams make is they try to anticipate every single edge case up front. They sit in conference rooms for months saying, well, what if the customer asks for a refund on a Tuesday, but their contract expired yesterday, but they're also the CEO's nephew?
And they try to write specific code for that one specific scenario.
They try to code for every possibility.
Which is impossible. You'll never launch the product.
It's impossible, and it delays the launch indefinitely. The solution is what's called adaptive architecture. You build a system that can handle the ambiguity, or, and this is the absolute key, a system that knows when it can't handle it and raises its hand.
That idea of raising a hand, of asking for help, leads us perfectly into the second part of this analysis, which is the philosophy of automation itself.
Yes.
Because I think a lot of people, executives especially, they assume the goal of AI is 100% automation. We want the machine to do everything right. We want to fire the humans and let the bots run the shop.
And that is the trap that absolutely destroys ROI. Vasiliman calls this the 80-20 rule of automation. And frankly, it's probably the most important economic concept in this entire deep dive.
Okay.
If you miss this, you lose money, period.
How so? Walk us through the math on that.
If you try to automate 100% of a workflow, you are going to spend 90% of your entire budget chasing the last 10% of the problems.
The edge cases. The weird stuff.
The weird, risky, complex situations. Teaching a machine to handle a standard refund request, that's cheap. That's easy.
Right?
Teaching a machine to handle a refund where the customer is threatening a lawsuit, their credit card is expired, and the product was bought in a different country 3 years ago.
Yeah, that's a nightmare.
That is incredibly expensive to engineer. You are trying to teach a machine centuries of human nuance for a case that happens maybe once a year.
So the juice just isn't worth the squeeze.
Not at all. The winning strategy, the one Ferric AI is seeing actually work in production right now, is to automate the 80 to 90% of cases that are frequent and predictable.
Okay, so you handle the bulk.
You let the machine handle the volume, the repetitive stuff.
And what about the other 10 or 20%?
You route them to humans.
See, that feels like a failure to some people, though. They'll say, if I have to step in, the AI didn't work. I paid for automation. I want automation.
And that is absolutely the wrong way to look at it. Using a human for edge cases isn't a bug. It's a feature of the architecture.
It's a design choice.
It's a reality check. It's smart design. And when you do this, you shift the role of the human employee. They aren't doing the mind-numbing data entry or the rote processing anymore. They become exception handlers.
Exception here. I like that title. It sounds more specialized, more valuable.
It elevates the job. The machine handles the grunt work, the sheer volume of noise, and the human provides the judgment, the empathy, the critical thinking.
This creates what the source calls a multiplier effect.
It's huge. Vasiliman's data suggests that when you get this right, 3 people can do the work that used to require 15.
Wow. Okay, now I have to play devil's advocate here because I know what our listeners are thinking.
Go for it.
If 3 people can do the work of 15, aren't companies just going to fire the other 12? I mean, that sounds like a very nice corporate way of saying mass layoffs.
It's the obvious fear, right? And I won't sit here and say it never happened. But the observation from the field, from companies actually getting value from agents, is the opposite.
How so?
They're removing the overhead.
Define overhead in this context. What does that mean?
Think about how much of your day is spent just preparing to do your actual job. Finding the right file, summarizing the email chain from last week, reconciling the data between two different spreadsheets, logging into some ancient portal to reset a password for the 10th time.
Oh, God.
That's overhead. It's the work about work.
It's about 60% of my day, if I'm being completely honest.
Right. So if the agent removes that 60%, you're not fired. You're just finally able to do the valuable part of your job, the part you were hired for.
There is nearly infinite work to be done in most companies. We're just usually too bogged down in admin and busy work to do it.
That's it, exactly. The agent clears the brush so the human can actually build the house.
So the goal isn't replacement, it's amplification.
It's about letting humans do what humans are uniquely good at: empathy, judgment, strategy, creativity, and letting machines do what they're good at: scale, speed, and consistency.
Let's shift gears a bit to the technology itself, because we talk so much about the model, GPT-5, Gemini, Claude. Everyone is obsessed with the benchmarks.
Oh, the horse race.
Yeah, who is smarter? Who scores higher on the LSAT? Who can write a better haiku about a stapler?
It's the supermodel myth.
The supermodel myth. Tell me more.
The industry is obsessed with the brain, the raw intelligence. But what we're learning in production is that the body matters more than the brain.
Body over brains. That sounds incredibly counterintuitive for an industry built on, artificial intelligence. Break that down for us.
Okay, imagine you have a genius, an Einstein-level intellect, truly off the charts. But this genius is trapped inside a glass box.
Okay.
They can't remember what you said 5 minutes ago.
Yeah.
They can't pick up a pencil or type on a keyboard. They have no nervous system to sense danger. And if they make a single mistake or get jostled, they shatter into a million pieces.
That's a pretty useless genius. You can ask them a complex physics question, but they can't actually do anything for you.
That is a great model with no architecture.
Right.
That is GPT-5 in a vacuum. It's brilliant, but it's disembodied. It's a brain in a jar.
I see where you're going with this.
Now, imagine a person of average intelligence. Solid, reliable, gets the job done. But they have a photographic memory for every interaction. They have a specific toolkit they know how to use perfectly. They have a strong nervous system that alerts them to danger. And they have a supervisor they can ask for help when they're stuck.
Right.
Who do you want running your accounts payable department? The genius in the box or the average guy with the tools and the memory?
The average guy, every single time. It's not even a question.
Every time. In the enterprise, architecture beats the model by an order of magnitude. Intelligence, real-world intelligence, actually lives in how the components interact. Memory, continuity, tool discipline, state awareness, error recovery, not just in the raw processing power of the large language model.
So we're over-indexing on raw IQ when we should be looking at what?
The spine.
The nervous system.
The spine, the nervous system, the hands, the whole body. A great model without constraints is dangerous. It's a loose cannon. And a great model without memory is just goldfish smart.
Goldfish smart. That's a terrifying concept for a business tool that's supposed to be handling money or customer data.
And there's a really strong economic argument here, too. The cheaper, dumber models often win.
Why is that?
Because they're faster, they scale better, and they are so much cheaper to run and debug. If you build a strong body, a strong architecture, you can always swap the brain out later when a better one comes along.
That's a great point. The models themselves change every 6 to 12 months at this point.
Exactly. If you build your entire system around the specific quirks of one model, you have to rebuild the whole thing next year. But good architecture, a well-designed database, good routing logic, solid guardrails, that lives for years.
So the strategy is to build a body that can carry the intelligence, whatever that intelligence happens to be next year.
That's the winning play.
You mentioned memory and this idea of being goldfish smart, and I want to double-click on that. The source material calls memory the silent killer. That's a dramatic title. Why is memory such a big deal? Don't we just paste the chat history into the context window? I mean, ChatGPT remembers what I said at the start of our chat.
That's the context window approach.
All right.
And it's a temporary surface-level solution. It's totally insufficient for enterprise work.
Yeah.
Vizuman says, and I'm quoting here, context is the whole game. An agent without persistent, structured context is just an expensive random number generator.
Give me a concrete example of a memory failure. What does this look like when it goes wrong in a business setting?
Okay, picture the amnesiac consultant.
The amnesiac consultant.
You hire a high-priced consultant. They come into your office. They are articulate, confident, very charming. You spend an hour on a whiteboard explaining your business strategy, your Q4 goals, your specific regulatory restrictions. They nod. They seem to get it.
Sounds good so far.
5 minutes later, you ask them a simple follow-up question, and they look at you with a completely blank stare. They've forgotten everything you just said.
I'd fire that consultant on the spot.
Of course you would. But that is how most off-the-shelf agents work today. They have session-based memory, but they lack structural long-term memory.
So what kinds of failures does that cause?
You see things like repeating actions, calling the same tool twice because it forgot it already did it 5 minutes ago. That's wasteful. Or even worse, contradictory decisions.
Contradictory? How so?
Imagine this. Step 3 of a customer service workflow is, we cannot offer a discount to this client because they are on the legacy plan. The agent reads that, acknowledges it, but then at step 10, the client asks again, but nicely, and the agent just says, sure, here's a 20% discount.
Because it completely forgot the constraint from step 3.
It drifted. It lost the thread of the conversation. The context window wasn't big enough, or the instruction wasn't reinforced.
Oh, that's a disaster. That's not just an error, that's actual financial liability.
It completely destroys your ROI because a human has to go in and fix the mess, apologize to the customer, and correct the billing. It creates more work, not less.
So memory cannot be just a prompt trick. It can't be an afterthought.
It has to be architecture. It has to be the spine of the system. We are talking about structured storage, databases, vector stores, real data infrastructure.
So not just a long text log of he said, she said.
No, if the agent takes a critical action, like sending an email or issuing a credit, it needs to log that event in a database. I emailed the client at 2:00 p.m. about case 123. So when it wakes up at 2:05 p.m., it queries the database and knows I don't need to email them again.
So we need context-aware recall. Step 10 has to be able to automatically and reliably reference the decision made at step 3.
Yes, and this brings up a new role, doesn't it? We used to talk about prompt engineers. That was the hot job of 2024.
6-figure salaries for prompt engineers.
That's old news. The new critical role is the context engineer.
Context engineer.
The person who designs how information flows, how memory persists, and how the agent remembers why something was done weeks or even months ago. That is where the real value is. The prompt is just the surface. The context is the entire ocean underneath.
This focus on custom architecture and deep structural memory really challenges the current market, doesn't it? Because right now, everyone is trying to sell us these easy sauce tools.
Oh, yeah.
Buy our AI agent. It works out of the box. Just install this one plugin and you're done.
And the statistics on that are absolutely brutal. The data shows most companies purchasing generic AI sauce churn within 6 months.
6 months, that's barely enough time to onboard the team and get it running.
It's because of what the source calls the one-size-fits-none problem. These generic tools, they hit a ceiling. They cap out at covering about 60% of your workflows.
So they can do the basics.
They handle the basics perfectly. Draft a polite email, summarize this PDF. But the moment you need to integrate with your specific, quirky legacy ERP system or your specific weird data silo that was built in 1998.
The grease trap of the enterprise, as you called it.
Exactly. The generic tool breaks down. It doesn't know your business. It doesn't have your context.
It's the tailored suit analogy again.
Right. A generic agent is an off-the-rack suit. It might technically cover you, but it doesn't fit right. It's baggy in some places, too tight in others. A custom agent is tailored to your organization's DNA. It fits perfectly.
But custom sounds expensive. Build your own. Scares a lot of CTOs and CFOs.
It is an investment, absolutely. I won't downplay that. But you have to look at the structural advantage. If you build a custom agent, you are building infrastructure that gets better over time. You own the brain. You own the memory.
And if you rent a sauce tool,
you're just renting. You're living in someone else's house. And since this space changes every single month, if you're renting, you're always dependent on your landlord to upgrade the plumbing. If you build, you own the whole house. You can renovate whenever you want.
So if a company is convinced and they're going to build custom, where should they start? Do you try to rewrite your whole customer service stack from scratch?
God, no. Please don't do that. The sources are very clear on this. Start with sales enablement and finance.
Why those two specifically? What makes them the best starting points?
3 things. High repetition, structured data, and a clear economic impact.
Okay, break that down.
Sales agents that prep sales reps for calls, summarize previous interactions, and manage follow-ups. That's a huge volume of repetitive work.
And the data is mostly in a CRM, so it's structured.
Exactly. Then you have finance agents that reconcile data between two systems or flag anomalies in expense reports. That's pure money saving.
Yeah.
You can draw a straight line from the agent's work to the bottom line.
You want to deploy where the feedback loop is fast and the dollar value is high and unambiguous.
Yes, don't start with something fuzzy like creative brainstorming. Start with reconciling invoices.
Boring is better.
Boring pays the bills. And boring data is usually cleaner data, which makes the agent much less likely to hallucinate and do something unpredictable.
Okay, so we've built the body, we've given it a robust memory, we've decided to go custom instead of generic. Now we have to talk about the scary part. Security.
This is where the conversation needs to get very, very serious.
Yeah.
Because we are making a fundamental shift from building chatbots to building actors.
From passive to active.
A chatbot talks. If it makes a mistake, it says something dumb or offensive.
No.
It's a PR problem, maybe a brand risk. But an actor does things. It has hands.
It can execute code, move money, send legally binding emails, delete files.
An unsecured agent is not just buggy software. It is, and this is another direct quote, an insider threat you built yourself.
An insider threat you built yourself, that's a chilling phrase.
It should be. The mental model here has to be, treat an agent like a junior employee on their very first day.
Okay.
Would you give a brand new intern the admin password to your entire customer database and just say, go wild, kid, figure it out?
Absolutely not. I wouldn't even give them the Wi-Fi password without a 20-minute lecture on our security policy.
But that's what we are effectively doing when we give an agent an API key with full permissions. We are creating 3 brand new attack surfaces that security teams have never had to deal with before.
Walk us through them. What are these new threats we need to be worrying about?
The first one is context poisoning.
Context poisoning, what does that look like in practice?
Since the agent relies on its memory and its knowledge base to make decisions, if I can slip a piece of bad data into its context, maybe a fake policy update document or a cleverly corrupted spreadsheet, I can slowly and silently corrupt its judgment.
So it's not just about feeding it bad data for one query. It's about changing its entire worldview.
It's worse than bad data. It's bad reasoning. The agent will then confidently and logically do the wrong thing because its memory, its foundation of truth, was poisoned.
It's like gaslighting the AI.
It's exactly that. You're altering its reality. The second attack surface is tool misuse or escalation. Every tool an agent can use is a potential privilege escalation. If an agent has a tool to issue a refund, what's the limit on that? Can it refund $1 million? Can it refund to a crypto wallet instead of a credit card?
Agents become overpowered interns if you don't scope their tools very, very carefully.
And they have no common sense to stop them. The third threat is agent-to-agent contagion.
Oh, this sounds like the plot of a sci-fi horror movie.
It's a very real problem in what we call multi-agent systems. We're starting to chain agents together now, right? Agent A does the research, passes its findings to Agent B, who writes the code, who then passes it to Agent C, who deploys the code.
Like a digital assembly line, a chain of command.
And if Agent A makes a subtle mistake in its research and feeds that bad data to Agent B, what does Agent B do?
It just assumes the input is correct because it trusts Agent A.
It trusts the input.
Yeah.
It acts on it, writes flawed code, and then feeds that to Agent C. You get a cascade of failure that spreads instantly across the entire enterprise.
And it's an emergent behavior loop that looks reasonable to each individual agent in the chain, but is catastrophically wrong in the aggregate.
Precisely.
So how do we stop this? How do we stop the contagion? The traditional answer in corporate security is gates. You put a gate up, stop, approval needed.
But gates create paralysis. If you put a human approval gate in front of every single action an AI takes, you've just lost the entire speed and scale advantage of using AI. You're back to manual work.
You've just invented a very expensive way to send an email.
Exactly. The solution isn't gates, it's guardrails.
What's the philosophical difference? Isn't a guardrail just a gate on the side of the road?
A gate is binary, stop or go. A guardrail is directional. It assumes movement. It assumes you're going forward, and its job is to keep you safely on the road.
This is the philosophy of constraint-driven autonomy.
I love that phrase, and it's true. Agents actually perform better when they are constrained. Ambiguity makes them sloppy and prone to hallucination. Boundaries make them focused and smart.
If you tell an agent, do whatever you want, it will hallucinate. If you tell it, you can only do X, Y, or Z, and only under these specific conditions, it gets much, much smarter.
It becomes a specialist.
Let's unpack the guardrail stack. What does this look like technically? What are the layers?
It's a layer cake of protection. At the very bottom, you have intent guardrails. This happens before the agent does anything. We validate the user's request or the agent's initial plan.
So you check the goal first.
Does this align with business goals? If the agent suddenly forms an intent to, say, download the entire customer database and email it to a competitor, we stop it before it even selects a tool.
Okay, so you catch the thought crime before the actual crime happens?
Exactly. The next layer up is action scope guardrails. These are hard physical limits. A rephoned agent simply cannot access the employee contract database. The permission does not exist. The wire isn't connected. It's hard-coded.
Hard limits. Non-negotiable.
Then you have confidence-based escalation. This is crucial. Think of it like a dial, not a switch. If the agent is 99% sure about its action, it proceeds. If it's only 70% sure, it pauses and flags it for a human to review.
So as uncertainty rises, autonomy drops.
Precisely. The autonomy isn't a binary on-off switch. It's a dynamic dial that is constantly being tuned by risk and context.
And I assume we need to be watching all this happening. We can't just set the dial and trust it.
That's the top layer, observability. Security without observability is just optimism in a business suit. You need logs, traces, replay capabilities. You must be able to rewind the tape and see exactly why the agent made that specific decision.
What document did it read? What logic did it use to get from A to B?
And you need rate limits too, right? So it doesn't try to refund 1,000 people in 1 second by mistake.
Blast radius limits, exactly. You throttle the execution frequency. If it does go rogue, the damage is contained to a small area before a kill switch is hit. You don't want it to burn down the whole forest. You want to contain the fire to maybe just one tree. So we have the diagnosis, the philosophy, the architecture, and now the security. How do we actually ship this thing? Because honestly, hearing all this, it feels overwhelming. It feels safer to just do nothing.
And that's the paralysis setting in. The mandate is start small.
Don't try to boil the ocean.
Don't try to build the omniscient AI that runs the whole company. That is a multi-year, multi-million-dollar recipe for disaster.
So you pick one workflow.
One narrow, high-impact workflow. You ship it early, maybe to a small group of users. You observe the failures in the wild, and you iterate based on real user behavior. You cannot brainstorm all the edge cases in a conference room. You have to discover them in reality.
And designing for failure seems to be the key theme here.
The question is not if something goes wrong, but when it goes wrong, and what happens next. Do you have a rollback plan? Does it escalate properly?
There's a great line in the source that says, security first actually means speed.
It sounds like a paradox, but it's true. Teams that prioritize security early actually ship faster in the long run because they have fewer catastrophic rollbacks and they build higher trust with their users and executives. They aren't terrified of pressing the on button.
Because they know the guardrails will catch the car if it starts to swerve.
Speed without control is not velocity, it's drift.
Speed without control is not velocity, it's drift. That's going on a sticky note on my monitor. That applies to so much more than just AI.
It does. And finally, you have to measure ROI immediately. From day one, you need to prove the value. Time saved, error reduction, cost avoidance.
Because by the time we get deep into 2026, the cool factor of AI will be completely gone. The honeymoon is over.
The board is going to ask, where's the money? What did we get for this investment?
And they're also going to ask about liability.
Yes, the model did it. Is not going to be a valid legal or corporate excuse. If your agent screws up and causes financial damage, the board, or maybe even a regulator, will ask, who designed this system? Who approved the permissions? Who set the guardrails?
That is the liability reckoning that is coming.
It's already started.
This has been absolutely massive. I feel like we've taken apart the entire engine of the AI agent industry and put it back together again. Let's try to synthesize this for the listener who is maybe prepping a pitch deck right now or designing a new system. What's the 1-minute recap?
The journey is from demo candy, the flashy, brittle, impressive-looking stuff, to production steel. Real, durable, reliable systems.
Okay.
To get there, you have to stop obsessing over the model's IQ. You have to stop chasing benchmarks. You need to build a strong body, resilient architecture, structured long-term memory, and deep security guardrails.
Body over brains.
Body over brains. And remember the 80-20 rule. Don't try to replace humans. Use the agent to handle the 80% of volume so your humans can apply their judgment to the critical 20%. That is the real path to abundance.
It's a fundamental shift from viewing AI as some kind of magic wand to viewing it as infrastructure. It's plumbing, it's electricity, it's steel.
It's foundational infrastructure that needs to be built to last, to withstand the storm.
So here is our final thought for you to chew on. Vasiman said something that really stuck with me. He said the most dangerous AI isn't the malicious one, the one that's trying to cause harm. It's the one that is confidently wrong.
It's the agent that smiles and gives you a thumbs up while it's quietly deleting your production database.
So ask yourself this. If your AI agent makes a mistake today, does your system have the memory and the architecture to learn from it tomorrow? Or is it destined to be a goldfish, repeating that same mistake forever?
That difference, the ability to learn from error, is what separates a toy from a true teammate.
And that is the deep dive. Thanks for listening. We'll see you in the field.
Stay safe out there. It's messy.